because many members are involving in the aspects like if I'm talking about the DE. Okay, so data engineering. Okay, let me give you the context. Loading the data, and then pre-processing the data, and apart from that, this pre-processing may involves missing value imputation, encoding, scaling, and feature engineering. Okay, so the main tasks of the DE: loading the data, pre-processing of the data, missing value imputation, encoding, scaling, and feature engineering. We know that loading of the data from various sources, maybe CSV, JSON, Parquet, like that. And of course, loading of the data related to the data frame or RDD, the tool set if you observe. Pre-processing involves many aspects, guys. Like, you have to curate the data, because if you consider the real-time data, friends, especially the log files and all, they are not in the proper shape. They are not in the um, in the usable format directly. So what you can do is you can perform some sort of the pre-processing mechanism. Uh, that particular pre-processing involving curation of the data, curating the data according to the requirement of the algorithm, so that data along with the algorithm becomes the model. So that model is a product actually. That model is a product where you can fit the model and as well as the predict the corresponding outcomes. All these things comes under the category of the handling of the data related to the before handling the data to the machine learning engineer. And missing value imputation and encoding, scaling, feature engineering. And of course, guys, 90% of the work related to the data engineering involves these four. Missing value imputation, already we have seen like how to handle. Okay, so null values or unknown values. Okay, so with the compensation of removing the appropriate column, or else you can remove the row. Sometimes you can add some additional columns so to handle that convention. And thereafter we have seen the other aspect, maybe mean, median, mode, okay, replacement and default value sometimes. And with the help of the linear regression also, we observed the imputation. And here encoding, guys, just we are having the encoding techniques, dummy encoding, one hot encoding. Okay, so target encoding with the help of the uh, probabilistic analysis and all these things we have seen as a part of the encoding technique, like handling of the categorical data and how we are making use of conversion process and all. Scaling, I'll take some example, guys, in the upcoming session tomorrow, like standardization and normalization. Most frequently used kind of the constructs, standardization and as well as the normalization, which is coming under the category of the scaling. And feature engineering, uh, generally, guys, features which are there, which are existing in the data set may not be enough to come up with the analysis. Maybe I can say, suppose salary value is there, but I want to, this is the annual salary, assume that, but I want to get the monthly salary kind of thing. Okay, so just I need to establish a kind of the feature. Or whereas another important thing is I want to get greater than 5 years experience in DE and I want to promote them as a senior DE or something like that. So this is also engineered feature. So the feature engineering involves predominantly we have seen some examples with the column. If you remember, guys, with the column aspect with the usage of with column, we have done this feature engineering. Okay, so the DE's activities involve all these kind of the functionalities, and we may be observing this scaling. Scaling is something like age, experience, sal. Generally, guys, this is a digit. This is also two digit, and this may be 5, 6, 7. It goes on. The problem with the algorithms is, guys. Okay, the problem with the algorithms is like obviously the salary is having more magnitude compared with the age and experience. The algorithm give high priority to this thing. Okay, which may not be required in our analysis. So as to handle that particular convention, what we are doing is this age, experience, and salary. We are going to turn into 0 to 1. Some common scaling. Okay, some common values or common scaling, so that algorithm is not giving any not given any wrong impression on the data, because your algorithm is having certain assumptions, guys. Even we have seen that assumptions in the regression. Okay, so that particular regression is also parametric in nature. So these algorithms are under the impression of if I am repeating more values in the data set, or if my data is having heavy values, the algorithm may feel that, oh, this data is definitely helpful for the analysis. So as to we need not give any prior information to the algorithm, guys, because if you are giving the prior information, it is going by our information, it is going by our analysis. But what we need to do is learning by data, whatever the data we are having. But as a human being, you may not able to estimate what exactly the data is saying to us, or which are all the patterns, and you may not observe. But just by picking up some kind of the sample data, it may not worthful so as to complete the analysis by the human view. So that as much as possible, we are not going to give our guidance to the algorithm. Rather, algorithm need to decide, your model need to decide which are all the observations, and from that particular model you can get the insights. That is the main idea. So what we are doing is just we are as much as possible, our interference must be less. We are all striving for handling those kind of the conventions with these approaches, guys. Missing value, encoding, scaling, feature engineering, all those kind of the aspects. So here the tool set used, because in terms of the tools, maybe you can use the Spark along with Python, of course, PySpark, and few members are using the Scala also related to the implementation. And additional tools you need to work, okay, because like Hive you can make use, or SQL context you can make use. At time, guys, there is a separate genre for the big data skill set also. Okay, like maybe the members are having the idea of HDFS, maybe they are having the Scoop or Flume, okay, and as well as some Kafka, these things. And nowadays, we are having one or two members in our team so as to handle these kind of the convention, which is a distributed file system, and this can be used as a base for this Spark. Okay, Spark running on top of the ARN generally expect the Hadoop distributed file system. That day we have seen how HDFS is helping Spark, helping in the sense extending its support, because Spark is not meant for the storage, guys. It is for the processing engine. So if you want to perform, if you want to analyze heavy data, and we ask this question, why we need heavy data? Simple. If I'm having plenty of the data, I may get plenty of patterns, and I can talk more about that particular data. Rather, if I'm satisfying with 100 records or 1000 records, that data might be biased. Biased in the sense only some of the people or some set of the ideas we are getting, we are unable to get all the functionalities of the data. So in that particular case, friends, obviously you will end up the corresponding analysis with less pattern observations or less implications. Okay, this is what how you can specify the usage of Spark and Hadoop distributed file system. Apart from that, guys, this is the scope where if I want to get my data from MySQL or Oracle or SQL Server, whichever, because it is a quite handy tool to handle all the relational kind of the data items. And once you are having this particular scoop knowledge, maybe you can pick up the appropriate source relational data into your Hadoop distributed file system, which in turn given to the Spark. So the relational model kind of the aspects are handled by the scope. Flume, certain aspects like Twitter, maybe I want to access some tweets and all, which is semi or unstructured data. Okay, so in terms of this scope, we are clear that just we are having the relational model. From that relational data, just we are posting our data into the Hadoop distributed file system, which will be placed in the Spark. Again, Spark can use that data. Whereas if you are making use of the unstructured data or semi-structured data, then obviously your Scoop is not unable to process that unstructured data or semi-structured data because it is completely dedicated to the structured data or relational data kind of the things. So Flume generally gives this APIs. Okay, with the help of the Twitter API, you can make use of this semi or unstructured data processing. Kafka is a most famous tool, guys, like where you can maintain the streaming process. And of course, instead of Flume, nowadays people are using Kafka to handle the semi or unstructured data handling. Okay. And of course, if you remember the point we discussed in the Hadoop ecosystem, um, like, so just I'm making use of this Hadoop distributed file system as a base. And they actually the combination here is, guys, simple. So if you consider the Hadoop ecosystem, it is mainly composed of two components, Hadoop distributed file system and as well as the MapReduce. This is a storage logic where if you are referencing the MapReduce is a programming or processing. So this particular storage, of course, distributed in nature. Okay. Whereas if you are considering the processing, parallel and distributed. Okay, so these two functionalities are making use of the convention. So any ecosystem tool generates the data. Maybe that is a Scoop or Flow or MapReduce. Okay, whichever. All these things are by default using the Hadoop distributed file system. And once the data is available, then it can be given to Spark. Okay, Spark can access and process the data. But there is a specific programming model, guys. Actually, there is a specific programming model related to the Hadoop, where that is nothing but the MapReduce. MapReduce example we have seen, like it is expecting some sort of the key value pair, so mapper and as well as the reducer, and with the help of that business logic, one can achieve the convention of key value pair. And you may not implement every application in MapReduce because that is a model which is having its own setup of the key value pair and all the four stages like split phase, map phase, shuffle phase, and as well as the reduce phase. Every data item, okay, whatever the input data item should follow up these kind of the convention. Moreover, this is a batch. It is a batch processing kind of thing. Whereas your Spark provides you the interactive, iterative, and real-time streaming also. Okay, so these are all the benefits of the Spark, but with the support of the Hadoop distributed file system, Spark can achieve, Spark can access a huge amount of the data so that your analysis part becomes handy and as well as more reliable compared with the lesser data. So these are all the tool set, guys. Like, let me consolidate the tools. Maybe you can use the Google Colab with the support of the PySpark, and or else you can use the Databricks Community Edition or proprietary, which is of course supporting Scala, PySpark, SQL context, and R. All these things by default supported by Databricks. Or else, nowadays we are using the clusters also, guys. GCP, AWS, and Azure, where your customization. Okay, according to your requirement, just you can based on the provision, based on the requirement, just you can ask the things. Maybe mainly we are using the Cloudera Hortonworks platform, guys, so as to handle all the Spark, Air, and all those kind of the conventions. So, and of course, within the PySpark again, it is enough to have RDD data frames and some sort of the optimizations. Okay, so these are all the reference of the DE. Okay, data engineering members need to have a focus on this kind of the context. Whereas if I'm talking about the ML orientation, machine learning context, it's a slightly different kind of the aspect. So if you are referencing the DE, from DE we are getting the curated data. Okay, now we are quite handy with our data set, and we are pretty sure that our DE friends done all the curation of the data. So now we are getting with the data. Now what you need to do is just we have to get this particular data and load the data into our data frame. And once this loading process is over, just we have to understand the data. Insights are there, na? Understand the data. And once this particular thing is over, selection of the algorithm. Mentally, you have to fix, oh, this algorithm is good. And then as we have seen, train and test split. So this particular train and test split, 75% training data, 20% testing data, or else the appropriate portion would be 80-20 also at times. And few people prefer 70-30 also. It all depends on the team discussion, and as well as whether we need to give more scope to the testing rather than the training, or else more scope to the testing. Okay, then you can go with this option, or else you want to train the model and testing, of course, enough to handle with 20% of the data, then you can go ahead. And once this train test split is over, so the next important aspect is model fit and as well as the prediction. Okay, prediction of the model. And thereafter, guys, the ML engineers or developer activities up to this act, these are all the major functionalities, friends. Now, from this particular point of thing, the data scientist functionality, because data scientist should have the capabilities of DE and as well as ML. Along with that, okay, along with that, this data scientist may be SME kind of thing, domain expert. Okay, along with visualization techniques, and then interpret the results. See, friends, here there is a clear distinction. To be frank, the machine learning developer responsibility is to acquire the data set, load it, and accordingly try to understand the data and observe which kind of the algorithm. Maybe if you are working with the classification, you can select support vector, machine, naive Bayes, decision trees, random forest, all these things. And whereas if you are talking about the regression model, just maybe that is the linear regression or multiple regression, polynomial, something like that. And if it is the unsupervised learning, there is no label kind of the data. So just we can go ahead with the clusters, clustering mechanisms and all. Once that is that has been decided, then splitting the data based on the proportion or portion of this particular testing and training. And once your train test data is ready, just you can fit the model with X train and Y train. Once that is over, just you can manage the predictions with the X test. So whereas we are going to get the Y prediction, and there you compare your Y prediction with your actual Y test. Y test is the original data from the data set, and this is the model constructed data. So just to understand uh, the narrowness, so how close our model estimated the appropriate thing, based on that convention, you can follow up the functionality. Okay, right. But once this particular thing is over, guys, the data scientist should be a member who presents everywhere, maybe in terms of the data engineering kind of things, where he need to decide whether I need to apply the scaling or which kind of the pre-processing techniques I have to use in terms of the encoding, whether we go with the dummy or one hot encoding kind of thing, all the provisions, all the support provided to DA. In terms of the machine learning engineer also, machine learning development also, just he's suggesting some optimizations, maybe hyperparameter tuning, or else, guys, just making use of the corresponding algorithm, uh, all those kind of the conventions. Okay, so because as a senior member, as a subject matter expert and domain expert, may not be all, guys. That's what I'm saying. Maybe sometimes in our team we should have the statistical background members also, because as I said earlier, there are certain metrics, with the help of the metrics only one can explain or interpret the results just by seeing the data, and sometimes visualizations also may not give the proper understanding of the data. So in that particular case, with the help of your metrics, okay, and we have discussed this particular metrics many a times. Confusion matrix, AUC, ROC, F1 score, accuracy, precision, recall, sensitivity, all these kind of the things belongs to the metrics of the classification. Whereas if it is the if you are working with the regression kind of the models, your metrics are different. Root mean square error, root absolute error, R square, adjusted R square, all these kind of the conventions you can use with the help of the regression analysis. Okay, so based on that conventions, one can easily observe. So the interpretation of the data, he need to explain, oh, these are all the patterns, storytelling kind of thing. That is what how you can refer the process. Okay, so then we are going to talk with the DevOps engineers so that to deploy our model, and that is a different genre, guys. Okay, so these are all the context actually. Okay, and in between, there are data analysts where they provide us some support in terms of the lake house or in picking up of the ETL process. Okay, some sort of the pipelining, all these kind of the aspects are coming into the picture. If you are talking about the data analyst, the data analyst responsibility is to liaison. Okay, to liaison between the DE and ML kind of the things, and moreover, the pipelining process, lakehouse usage, all these are the aspects provided by the data analyst. Okay, so sometimes maybe interchangeably we are using the functionalities, roles, and responsibilities, because that's how the data science genre works, friends. It's not like, we cannot see the data engineers, data analysts, and machine learning engineers as a separate part from the data science genre. And integration of these things also a bit tricky. Okay, sometimes ML member should perform the activities of the pre-processing. It happens because maybe the DE members would have provided the notebook for you, which they have done some sort of the pre-processing aspects. But maybe you are not okay, or else you want to develop, or you want to establish a kind of the pre-processing related to your algorithm, because at the level of the DE, data engineer may not know about which of the what is the algorithm you are going to use and all. So maybe in his or her context, he would have done a standardized pre-processing technique. But later point of time, you may need to repair and you may need to add some more functionality. That's what I'm saying. So the roles and responsibilities. Okay, and if DE members are pretty know about ML development and usage of the algorithms, and they can fine tune the appropriate work in a better way. And similarly, machine learning developers also, if they are aware of all these kind of the conventions like pre-processing, loading of the data and all, themselves they can achieve additional functionality. Okay, so Shelby, sometimes these roles DE and ML we cannot vary it also in some of the organizations. So all members are having the capabilities of loading, and until the interpretation of the results, they are having complete knowledge. Okay, but in the companies like high level support would be there, and many members are there in the data science team, so that there is a clear separation of the tasks. Okay, and in this case, guys, so what exactly we are using? Maybe the tool set, or else kind of the functionalities. Mainly the algorithms we have to use, guys. And as of now, we are using the scikit-learn library only. Okay, but still there is a separate thing is there, guys. Actually, MLlib is bit now bit complex. Why I'm saying this complex is scikit-learn library. So as a kind of the package, so just it is providing along with the scikit, we are having the cburn, matplot, and then we are having numpy and pandas. These are all the rich as of now, guys. Maybe in the upcoming days, our Databricks guys or researchers maybe releasing the competent packages related to the MLlib. Because now full-fledged MLlib libraries are available, but only the thing is just that particular assembling or vector assembler, and moreover, we are dependent on the pipelining aspect. Okay, so directly we may not achieve the functionality as that of the scikit-learn. In the scikit-learn usage, it is very flexible. Directly, I can make use of the what you call fit and transform, and predict all these kind of the things, and thereafter scale and transform, encode and transform, like that. There are multi-facet activities, but in MLlib you have to do individually, and then you need to perform some kind of the pipelining, except that uh, those particular MLlib kind of the libraries are competent with the scikit-learn. Only in terms of coding and flexibility, just they are a bit lagging, and I am sure in the coming days definitely they are going to have the same kind of the setup, or at least they are going to merge up. They are going to have some sort of how we are doing our. If you consider the kind of Databricks orientation, and we are using SQL context. Okay, similarly, we may get the scikit-learn kind of the API directly, so that you can activate the things. So this is how you can perform the logics. And of course, RDDs and data frames, as usual, you can use, but metrics, your metrics, algorithmic knowledge, and fine tuning of the hyperparameter tuning techniques, all these are the functionalities. Okay, as I said, just you need to have the algorithms, and as well as hyperparameter tuning, and thereafter measures or metrics understanding, and most important skill, guys, data storytelling and visualization or interpretation of the data. Okay, interpretation of your findings. So this is what how you can specify the usage of a data scientist or machine learning kind of the context. Okay, now let me pick up the persons guys who are ready to present. Okay, let me open that. Where is the Databricks? Ravi says few minutes. Okay, Ravi, no problem. Take care. Hmm. So please respond back, guys, who are all there in the call. Henry, are you there? May not be. Jay Prakash.
Yeah, Pawan.
Yeah, okay. Thank you. Jatin.
Yeah, Pawan.
Okay, thank you. Kannan. Kannan must
Yes,
be
Pa.
there.
Yes, Pa.
Okay. Krishna, I'm not sure. Krishna, are you there? In project. Okay. Mayur.
Yes.
Okay. Arif.
Yeah, Pawan.
Very good. Monu. Monu is not there. Naveen.
Yes,
Okay.
Pawan.
Yeah, Naveen also there. Maybe Harishita and Pawan, they are going to talk tomorrow. Okay, we'll start with JP then, Jay Prakash.